Okay, there are a couple of study designs that you can select from that rely on two related samples. So that is to say, two samples that are dependent upon one another, or two samples of data, sorry, that are dependent upon one another. So these are observational multiple sample designs or experimental crossover designs. Now, let me explain how you may have a study design that fits within these, but that you've got related data. So, typically you have one sample of individuals, though not always. I will provide an example that is slightly different to this as well. You will have collected data on a continuous variable from these individuals, but you've collected that data twice. So you've collected it under two conditions. That might be pre and post some intervention, or at two different time points, or it may be in the context of a crossover design where you've collected data under two different intervention conditions. And what you're interested in is how those two sets of related data, and we say they are related because they are two samples of data that have come from the same sample of individuals, and you're interested in how they differ from one another. So let's visualize a few different examples of this that might relate to research questions that you are designing studies for. So, you might have a single sample of individuals that you start off with, but you collect data, for example their body weight, at one time point, and then from the same sample of individuals you collect their data again at another time point. Now, because these measures have come from the same individuals, we say that we've got two related samples of data. It's one sample of individuals, but we've got two samples of data that we've collected and they are related to one another. And we may be interested in comparing those two samples of data. We may have a sample of individuals that we want to compare interventions in. So this is the traditional crossover experimental design that you can select. So for example, we might want to compare lifting weights versus running. So we have our individuals randomized so that one group lifts weights, one group does some running, and then they swap over and they do the opposite intervention, and then we want to compare these two. But this data has all come from the same sample of individuals, and so the different samples of data that we have are related to one another. So we'll be comparing weights to running, but these sets or these samples of data will be related because they come from the same sample of individuals. Another example where you may have two samples of individuals but you still have related samples of data is in a type of observational multiple sample study design, which is called a matched design. So for example, you might have two groups and you decide to match them on their body mass. So for example, you might have 10 individuals in one group and 10 individuals in another group, and you try as close as possible to match them so that they are paired up between groups by their body mass. And then you want to compare, for example, the strength measures between the two groups. So for example, this might be males and females, and you want to see whether or not there is a difference based on strength that isn't explained by their body mass difference, and so you match them and then compare their strengths between the two sexes. So in this case, because you have matched on them, the two samples are also related. So typically what we have in our two related samples design are these pairs of observations for our y variable, the variable that we're interested in, our outcome variable. So we can think back to our single sample regression model, our single sample general linear model, and have an intercept only model that is interested in predicting the differences between those two y values that we've collected. So we can simplify this such that we calculate the differences between y1 and y2, and we have essentially an intercept only model on the paired differences. This essentially becomes a one sample t-test on the paired differences. And this is often what is called a paired samples t-test. Of course, similarly to the one sample t-test that we referred to in the previous video, there is a non-parametric version based on the signed ranks of the differences between the variables, which is called a Wilcoxon test similarly. Again, there will be a video to show you how to do these analyses and their equivalents in JASP.